What if somewhere, far beyond our solar system, another Earth is waiting? A world with familiar sunlight, rocky ground beneath alien skies, and the possibility, however faint, that life could exist. Not just microbial, not just chemical traces in ancient rock, but life. Real, breathing, reaching for the stars life. Its name is Kepler-452b. Discovered in 2015 by NASA's Kepler Space Telescope, Kepler-452b quickly earned a nickname that captured global imagination, Earth's cousin. The announcement reverberated through laboratories, living rooms, and late-night conversations around the world. For a brief moment, humanity looked up, collectively, and wondered. But what makes this distant planet, located over 1,400 light-years away, so special? Kepler-452b orbits a star strikingly similar to our own Sun, a G-type star, slightly older, slightly brighter, in what scientists call the habitable zone. This is the sweet spot, not too hot, not too cold, the Goldilocks region where liquid water, the universal solvent of life, could pool on a surface, flow in rivers, and fill great seas. And where there is water, there is potential for life. Its year lasts 385 days, remarkably close to our own 365. It has lived beside its star for an estimated 6 billion years, 1.5 billion years longer than Earth. If life ever had a chance to take hold there, it had time. But there's a catch. Kepler-452b is about 60% larger than Earth. That might not sound like much, but in planetary science, size is everything. A planet that large could have gravity nearly twice as strong. Imagine every step requiring twice the effort, every breath drawn against a denser, heavier sky. It might be a super-Earth, rocky, geologically active, rich in minerals. Or it could be something far more hostile, a mini Neptune wrapped in layers of gas, crushing pressure and perpetual storms. We don't know if it has oceans. We don't know if it has continents. We don't even know if it has an atmosphere, because Kepler-452b was found using the transit method. When a planet passes in front of its star, it dims the starlight by a fraction of a percent. That dimming, almost imperceptible, is the only evidence we have. All we have is a shadow, a tiny dip in starlight. So the question remains, could humanity ever call this world home? At first glance, Kepler-452b checks many of the right boxes: stable orbit, sun-like star, potentially rocky surface, and age that suggests geological and perhaps biological maturity. But the challenges are staggering, and they begin long before we arrive. At the speed of our fastest spacecraft, the journey to Kepler-452b would take roughly 26 million years. Even at the theoretical limits of near-light-speed travel, technology we do not possess, it would consume thousands of human lifetimes. And even if we arrived, what would we find? A paradise of blue oceans and breathable air? Or a pressure cooker world with crushing gravity, volcanic skies, and an atmosphere too thick to survive? We simply do not know. And perhaps that uncertainty is the point. Kepler-452b is just one of over 5,500 confirmed exoplanets discovered in recent years, with thousands more awaiting confirmation. Each one a possibility, each one a question mark hanging in the dark. Astronomers now believe that most stars in our galaxy host at least one planet. In the Milky Way alone, with its 200 to 400 billion stars, the math becomes almost impossible to ignore. Even if only a fraction of those planets fall within habitable zones, even if only a fraction of those develop the conditions for life, the numbers suggest we are not alone. Are we the exception? Or are we simply not looking far enough yet? With next-generation telescopes like the James Webb Space Telescope, scientists are beginning to do something once thought impossible: analyze the atmospheres of distant planets. By studying the light that filters through a planet's atmosphere during a transit, researchers can detect chemical signatures, carbon dioxide, methane, water vapor, even oxygen. We are, for the first time in human history, developing the tools to smell a planet from across the cosmos. Kepler-452b itself may be beyond James Webb's reach. It sits too far, its star too bright. But the techniques being refined today on closer worlds will one day be trained on planets like it. Kepler-452b may be out of reach for now, but it represents something far greater than a single planet. It represents a proof of possibility, a glimpse of what the universe is capable of building, a reminder that Earth might not be unique, that the same cosmic forces that shaped our world, gravity, water, time, and starlight, could be at work right now, somewhere 1,400 light-years away, building something, sustaining something, perhaps nurturing something. And that somewhere in the vast and patient darkness of space, another world could be waiting, not just to be discovered, but one day to be explored. Kepler-452b, Earth 2.0, humanity's next chapter. What if Earth isn't the only Earth?